tuning in. I'd like to just deal with solids in stoichiometry. Okay, there we go. So I've got a very long, daunting equation. Now it will look very difficult, but is calculating and reaching the conclusion, desired required conclusion, is quite easy. It's not a challenge at all. So if we've got 4 moles of ammonia reacting with 2 moles of sulfur dioxide and 1 mole of oxygen to give us and don't forget there's 2 moles of water involved in there as well. And if all of these, the reactants, reactors to give 2 moles of ammonium sulfate, how much ammonium sulfate is being produced every day if the plant captures 64 tons of sulfur dioxide. So what mass of ammonium sulfate is being calculational is being produced when 64 tons of sulfur dioxide is being captured by the plant every single day. So what we can do is we quickly need to jump on to calculating the MR, the molecular mass of sulfur dioxide, which would be S plus 2O, which will be 32 grams per mole, plus 2 into 16 grams per mole, and overall it will be 64 grams per mole. So we've got 64 grams per mole. We need to ignore the 2 here for now, because when calculating the number of moles, we need to ignore this 2. We need to ignore it. We can't have it here. So now what we'll do is we'll calculate the number of moles by the mass divided by the molecular mass. So that would give us 64 tons, which is 64 ton. 1 ton is 1,000 kgs. So 64 tons would be 64,000 kgs, which would be 1,000 grams. That would be 64 million grams, and divided by 64 grams per mole. So that will be a million moles. Now, folks, if this is million moles by ratio proportionation, because both of them are bimolar, ammonium sulfate and sulfur dioxide, both of them have equiproportional molar ratio, equiproportional molar ratio 2 by 2. So the number of moles produced from 2 moles of sulfur dioxide would be 2 moles of ammonium sulfate. Hence, from a million moles, assuming negligible chemical reaction kinetic losses and negligible plant manufacturing systematic losses and inefficiency losses, we would get a million moles of ammonium sulfate. So we quickly need to, first of all, before we can get the answer, we need to find out the actual number of for ammonium sulfate by calculating the molecular mass, which would be N. So we know ammonium ion is 14 plus 4 into 1 times 2 plus sulfur dioxide. That'll be 32 grams per mole for sulfur, plus 64 grams for the 4 atoms of oxygen. So we'll get 14 plus 4, 18, 36 grams per mole for ammonium ion complex, and then we'll get 64, and then we'll get 96 grams per mole. So 96 and 36 gives us 132. 132 grams per mole, and if we multiply it by that, we get 132 million grams, which would be kgs, 132 tons. The answer would be 132 tons. So we could see that we started off from 4 moles of ammonia reacting with 2 moles of sulfur dioxide with 1 mole of oxygen to get with 2 moles of water to give us the product, which is 2 moles of ammonium sulfate. Now, before, to cover our back, we will need to calculate the molecular mass. Then we'll have to calculate the number of moles. So we get the number of moles of sulfur dioxide gas. Then we know that it has equiproportional molar ratio. So we quickly jump over to calculating the molecular mass for ammonium sulfate, and then we multiply it with the number of moles. And once we do that, we get 132 million grams. That would be 132 tons. So that's the number of. So 64 tons of sulfur dioxide produces 132 tons of ammonium sulfate, and that's. I mean, it seems elaborate, but it's quite straightforward. The shortcut is calculating the number of moles quicker in the sequence. Hence, you reach your destination earlier. So I hope you enjoyed this. Thank you very much.